computer and start. Right, good evening, everyone. Welcome to this seminar or webinar, I should say, on digital twins in mining. My name is Mohsen Kalantari. I'm associate professor and faculty member of University of Melbourne's Faculty of Engineering and IT, and also deputy director for Center for STIs and Land Administration. While the audience are joining gradually, I acknowledge and pay respect to the Wurundjeri, Woi Wurrung, Burrung, and Boon Wurrung people who are the traditional owners of the land. Our Parkville, South Bank, Werribee, Burnley, and Hawthorne and Fisherman's Bend campuses of the University of Melbourne are situated. We recognize the unique place held by Aboriginal and Torres Strait Islanders people as the original custodians of the land and waterways, and respect our First Nation people as the world's first engineers and scientists. It is my pleasure to welcome you to this event. This is a very special event. It is the first in our digital engineering seminar series as part of a bid for a training center on digital engineering of Australia's assets. So if you are interested in this center, please scan the QR code on the screen here. It takes you to the center website and explains what we are intending to do in the center. And if you like any more information, you're interested in the seminar, you can contact me. My email address is available on that website. Now, today's program is obviously on digital twins in mining, includes 3 presentations, each of them 20 minutes, and then we will have a panel discussion at the end of the presentations, including the presenters. Please feel free to post your questions using the Q&A, not the chat box. I will try to monitor both, but it will be easier if you can ask your questions Q&A. We can moderate that more efficiently. And also, I remind the attendees that we are recording this session. Now, we can start the presentations. I am very pleased and delighted to introduce our first presenter, Mr. Russell Mears. Russell, if you could please turn on your camera, is the manager of industry research and training, industry research and technology at METS Ignited. METS Ignited is one of the Australian government industry growth centers, and Russell leads the industry-driven research initiatives towards commercialization. Russell has worked over 30 years in over 40 countries in different continents and brings a wealth of knowledge in commercialization of technology. And he is going to talk on exactly that topic, and that is channels and challenges in commercializing innovation in technology. I stop sharing and then you can share your screen, Russell.
Fantastic. You can see that, Mohsen?
Yes, I can see.
Fantastic. Okay, thank you. Thank you very much for the introduction. And as mentioned, my 20-minute talk is really going to focus on commercialization, which is a really important topic these days. And I'll I'll give you a little bit of background about Mets Ignited and some of the things that we've learned in the duration of our program. And really, what we've seen is a fair amount of information that has led to how we can commercialize in technology. And this will apply to digital twins and machine learning and artificial intelligence in general. So what I'd like to do is tell you a little bit about Mets Ignited. For those of you that don't know us, as Mohsen has mentioned, it's an industry-led, government-funded growth center, one of the 6 industry growth centers that were set up by the government in 2017 by the federal government. And the focus is on mining equipment technology and services, the METS. And really, this department was set up by Department of Industry, Science, Energy and Resources federally. And since that time has been a recipient of funding from the Queensland and Western Australia governments for a number of different programs. So the goal of these industry growth center and under this overall initiative is to accelerate the commercialization of innovation, to enhance the industry skills and capabilities, and to grow our exports in areas that Australia has a proven competitive advantage. In addition, we had an initial scope of work that was to look at regulatory environments, interstate across Australia and nationally, and to identify if there were improvements that could be made surrounding the technology and the commercialization of technology. So what we do, we work with state, territory governments, we work with national peak bodies, which might be the engineering associations, mining associations, mining industry associations, as well as economic development groups regionally, all to support and grow the Australian METS sector. For some people, that might be a bit confusing because we're talking about the mining sector and all, but what happened back in 2016-17, so there was this a couple of studies that identified about 40,000 companies that provide services to the mining industry across Australia. Now, very few of those actually identify themselves only as suppliers to mining. Many of them are cross-sectoral, as you might imagine. They might provide services to infrastructure, highways and railways, civil works. They might provide services in artificial intelligence, for example, through to defense or other sectors. And what we wanted to do was focus originally on innovation and working through that mining equipment, technology and services, vendors and suppliers. What we found over this time is really that there's a huge body of support. There's over 1 million Australian jobs involved in technology in the resources sector. It's a big contributor to the national economy, and really the Australian technology outputs are world leaders and are used across the world in the mining industry. Australia is really highly recognized in this space of developing innovation, productizing and commercializing. And I'm going to talk a little bit more about that. So one of the things that we've done is we've delivered our work program through working with technology companies and resources companies to collaborate. And this is a key theme throughout the Mets Ignited program, is collaboration around the challenges and future needs of the sector. And we're looking at transformative change, which is also something that you see in the ARC, CRC bid applications, is how will your application transform industry. So this is a really key component to being the recipient of funding of many of these grants, is looking for those transformative packages. So what have we done in Mets Ignited? We've supported the development of clusters, which is a collaboration, so innovation hubs, clusters, and accelerators to develop commercial skills and capabilities. We've also delivered master classes throughout the program to help bring up the skills of technology leaders to be able to prepare themselves and to address their products to market. We also sponsor industry associations and often events like this webinar in an opportunity to get the word out about technology within the sector. So I think all of this really accumulates to more highly skilled jobs, huge economic value that's generated by the technology sector, and part of that certainly is into the mining space. MetsIgnite itself, just a little bit more that what we've done. For 6 years we've had this I think great value contribution to the Australia's met sector and mining. 5 years of operational experience, $13 million of project investment that we've invested in the sector. 26 projects we've invested in our collaborative project funding schemes. And that's benefited 66 companies and brought over 20 new products to the market. And those challenges are what I'm going to be talking about a bit later on, because every one of those projects face different challenges in bringing their products to market. Overall, this has resulted in about 650 new jobs, combined revenue of about $700 million up to 2025 is our projection. As I've mentioned, there's the project funding. We've also had these technology clusters where we've facilitated groups getting together and very effective groups in the sense of government, research organizations, end users in the resource industry, as well as the suppliers and vendors and technology providers. And those clusters have been extremely valuable at breaking down some of those silos and barriers and encouraging and enabling sharing of information, not only data, but also information about how to capitalize and optimize their businesses. So the technologies that we've been involved in these clusters have really, they've been certainly mining, energy, defense, but also space. So we've been involved with NASA and in looking at space mining missions, for example, which is quite interesting. Been involved in a couple of establishments, so the Future Battery Industries, CRC, Cooperative Research Center, and others would be, including the Electric Mine Consortium, which is a group of companies, vendors, end users that are developing electrification of mines. And some of those participants were recipients of our project funding, and others have been pulled together in these collaborative clusters. Really, I think that the value that we've seen is really amazing in the sector. One of the things that we've done over the last 5 years is regular updates of the business trends. And this is a theme I'm going to pick up on a bit later. As we often see in research projects, that there's an initial, say, a market assessment, a market scan, and then push into answering some of the key challenges. What we have learned is that it's very important to go back on a regular basis to reassess the market, to reassess how things sit. May it be competitors, competitive technology, it might be purchasers, it might be trends in the market. And the one I've got on the screen is really around, as many of you would have seen in this month of COP26, the COP26 in Glasgow, we've been seeing all kinds of information about net zero and target around net zero from industry and from government. And how do we get to net zero is really around critical energy minerals. So there's been a number of announcements from state and federal governments about funding specific to critical energy minerals. So minerals that exist in Australia that in some cases are mined, some are not, but they all contribute to the electrification and decarbonization of our future. So that's a key trend. And recently, environmental social governance is a number one trend when we talk to mining companies, end users, as well as technology companies. Now, this doesn't diminish the importance of safety and productivity, and those are always the drivers that are the foundations and pillars for businesses to stay in business and to treat their employees safely. And certainly in the mining industry, that's critical. But when we combine all of these things, we see that the solutions are coming from the application of technology. What else have we seen in the last couple of years? We've seen that the Australian research and development is so strong. You know, innovation is a great feature of our society here. But what we've seen is that many of those solutions are not available through a viable delivery model. So while we've seen a lot of fantastic innovation and development, there are challenges in the supply chain to get those through to the market. And I'm going to talk a little bit more about that as well. We've also been engaging a lot with investors, whether that be government grants, whether it be venture capital or traditional financing methods. And what we've seen is that there's a very low overall visibility of vendors to invest in. So a lot of the venture capitalists from overseas come to us and say, we really know who the innovators are in the universities and the research institutions. They've got a very high profile, which is fantastic. We also know who the big end of town, the big mining companies are, but we're not sure about that middle part of the ecosystem. Who's going to be supplying, developing, supporting each of those technologies, and where can we invest? And that there's a tremendous amount of investment capital that's seeking technology to invest in. And part of our role, I think, and everyone on this presentation is to help raise that visibility in the marketplace. We also see not only from net zero and decarbonization goals, but the resources sector has a huge demand for innovation, whether that's autonomous vehicles or digital twins, as we'll talk about later, or safety systems. There's a lot of demand for that innovation and technology, but there are challenges in aggregating that demand and translating it into the right research and innovation and productization. And the final point I'd like to talk about is stranded technology. So there's a lot of technology that's been built into industry. We've seen things that maybe in a research environment where they've got to a certain point and then the team has disbanded or moved on to something else. Sometimes we see it in resource companies where they identify maybe a 3 or 5 year investment plan, and partway through that, the environment changes, their global environment, and so they'll change tack. And so often there are things that are sitting on the shelf. They're at a certain technology readiness level, but they might not have champions, or they might not have the right investment, or they might not have the right market that's assigned to them. So this is a key a challenge in technology is helping free up and enable some of that stranded technology. So I think one of the things I want to talk about is just, you know, our mining DNA in Australia. So I'm originally from Canada. Should have mentioned that earlier. But one of the things Australia has, and one of the things that attracted me to Australia, was this mining DNA, this credibility around the world of really smart mining companies that have fantastic technology integrated into their operations. And a lot of that, Australia's led the way in safety in mining, have led the way in things like mineral processing and research, software technology, obviously. And we have to keep in mind that Australia is this, you know, each mine site is a very complex and remote operation, and understanding and dealing with all of those challenges is not easy. And that's helped push Australia up in that perspective of the global eyes for technology. So I think one of the things we often do is we then start to say, well, what's next? Let's see, is the technology itself the industry that's supplying, and primarily to mining, but it might be the same technology that will be implemented on other sites. We've recently worked with an autonomous vehicle visioning system and a company that's developing that technology, and found a place for that technology at ports to help ships berth. But they're also using that technology in the defense arena. So this is where this cross-sectoral technology and industry is really quite interesting. And one of the key backings to this is the federal government's announcements last year about the Modern Manufacturing Initiative and the Modern Manufacturing Strategy. And this is really about investing in local capabilities in Australia to support businesses to commercialize existing technology, what I was referring to as stranded technology in many cases, but to provide the scale and support to grow their businesses, certainly in Australia, but also to supply the rest of the world with this leading technology in products and services. I think what we envision is that the success here will create a skills framework that supports the whole industry, transforms the industry, in fact. And things like data and analytics and increasing the demand for skills in regional areas, as well as helping the transition from maybe a traditional mining method to autonomous machines. The data century is upon us, and how are we going to equip our rural communities, regional communities with those skill sets is going to be quite important. So this is the theme that keeps coming through, is this productizing stranded technology in the national economy. It's something that we've already spent a lot of time and effort and money on developing to a certain point. So we're in a process now of developing a mapping of some of those stranded technologies and mapping those to existing aggregated demand within the industry. And that's really how we can help fast track, in many cases, to sustainably adopt some of that innovation for the benefit and transformation of the whole sector. So I think the opportunity is really to help build these ecosystems, whether it's focused on decarbonization or productivity or safety. It's about building ecosystems, clusters where we have data sharing and information sharing and enablement across the industry. High global demands, certainly, as well as the demands in Australia for data analytics, robotics, and automation. Social license, as I talked about earlier, ESG and social license, and sustainable energy. So these are all really critical factors as we move forward. And this creates a huge opportunity for technology. One of the things we keep coming back to is what model is most effective in delivering this. And it's describing a landscape. It's describing a landscape of working together in collaboration. It's as you see on the screen, it's about industry bodies, community, government working together with researchers and vendors or met suppliers, providing end users with solutions to meet their current demands and problems. And interestingly, one of the studies that we had undertaken on our behalf by Queensland University of Technology, the Centre for Met's Business Innovation, they found that the vast majority of the patents in mining are lodged from Met's companies. And interestingly, we find places like Mackay in Queensland as being the highest per capita patents in Australia. And so some of that business research is really enlightening to see how that we as technologists can be most effective at transforming our research and technology into the industry. I think many of us are familiar with the technology readiness level, the TRL, as technology is developed through its innovation cycle through to productization and commercialization. And often we see that there's a host of organizations, government and industry funded, they target the development of those solutions. Unfortunately, the outcomes of these organizations are they're predominantly led by industry operators. Those are the people that receive the most benefit, certainly. But rarely do these convert locally to commercialized products that are available to the whole market. So we might see one, for example, an innovation center or a grant that's assigned to one university working with one end user with one or two vendors in the middle, and that's fantastic for that end user And it's fantastic for the research that's been initiated, but it doesn't transform the whole industry. So what we're looking for in METS is really to expand that much further. And that's how we're going to achieve the GDP growth that we need in the country. So what we're looking at is where each of these, and they're not fixed boundaries that I show on the screen in each of the organizations, certainly. Many universities have taken innovation and research all the way through to commercialization. There's some great examples of that. But how can we ensure that that happens more frequently and more often? And that's really the question that we're posing and putting to this group to see how we can be most effective in that space. So really, I just want to close out with this slide that look, METS Ignited. We've got other growth centers, for example, MIRA, the energy and oil and gas organization. We've had a track record of investing ourselves capital in helping some of these companies get through the most difficult parts of that cycle. Avoiding the valley of death by giving them a shot in the arm just when they need it. There's obviously following innovation and TRL. There's some key areas where that extra support is really needed. What we've found is that the collaboration and the clustering is a very effective way of bringing that through. You're able to share with other innovators, other people who have gone through that cycle. And it's more than an innovation incubator. It's more than an accelerator. It needs to be a whole ecosystem to help enable that development and commercialization in the market. So by understanding those challenges, those critical junctures in the development process, this is where we can transform industry. And I'm happy to say that I think METS Ignited, we've got a strong record in helping industry, and we want to continue accelerating that technology commercialization with our networks. So if there are any questions or comments or if people are looking for some pathways or channels to move that through, please be in touch, and we'll be very happy to help out. Thanks very much, Wilson. I'll stop sharing the slides.
Okay, thank you, Russell, for your presentation. Excellent overview of METS Ignited and also the commercialization ecosystem. I'm sure the audience will have questions for you. I do have some questions, but we'll leave that towards the end of the session where we will have a panel discussion. So let's move to our second presentation. I'm delighted to introduce Dr. Penny Stewart. Penny is the CEO of Petra. Penny, if you can please turn on your camera while I'm introducing. Penny is also a mining engineer, and she has track record of working as a mining engineer. As also, she has studied PhD at University of Queensland, has worked as an academic, and it's really a nice combination of experience in field as well as research and development experience. And Penny is going to talk about how machine learning basically optimizes the value chain in the mining industry. Penny, over to you if you want to share your screen. And you unmute yourself, please.
All right, I'm showing my screen now. And are you seeing my presentation?
Yes, but you need to go to full screen mode.
Yeah.
That's
okay.
Good. Thank you.
Excellent. All right, so the presentation that I'm giving this evening is on how mining professionals are using digital twin technologies across the mine value chain. And I'm sure that as we have different speakers this evening or this afternoon, you'll get an appreciation for the different ways that digital twin is being understood as a concept and the different applications. And I think that what I'm presenting to you is one type of digital twin. And I'll give you, just start off, I guess, with a bit of clarification on that. So digital twin has actually become, it did start off in the academic world at universities in 2002, and there is an academic definition. But in common usage of the word now, it's starting to cover a broader range of meanings. And that includes things like visualization of data. There's digital twins for the purpose of design that engineers are using, where they're not connected into the real world or linked into a physical system. There's operational digital twins, and then there's digital twins for simulation and also for maintenance. These are some of the ones that we've come across. But as technical people, and I expect that most people joining this call are technical, the way we explain it when we're talking about digital twin is that it's a type of model that is linked into the physical system. And that can be a visualization model, or it can be, like in our case, a mathematical model for the purpose of prediction, simulation, and optimization. But the difference is that historically engineers and geologists have built lots of different types of models, but those models haven't really been linked back into operations in any kind of coupled or twinned way. It's that linking, the twinning of the real world to the model that distinguishes it from other types of models that you may have come across in your engineering or geological career. So in mining context, those of us in operations or working in and around operations, it's really an opportunity to provide a fast feedback loop into our design and our planning and decision making. And in the past, that would have been done through a more manual process, like reconciliation that's done at the end of every month, and reporting. Now, the thing about reporting and reconciliation is that it's too late. By the time that you've done your monthly report and you've worked out what you should have been using as your inputs for your design and planning, you can't affect change. You can't actually you can adjust for next month and hope that the adjustments you make will result in an improvement on your ability for next month. But it's not, the time frame of every month is actually quite slow and limits the value that can be created from the data. But by linking it into a faster time feedback loop through digital twin technology, you can really start to use the data in a much more high fidelity or timely manner. So I'm not sure if you're aware, but we are one of those METS I'm the founder and CEO of Petra, which is one of the METS companies that was just been mentioned in the previous presentation. And what we are doing is helping mining professionals to use the digital twin technology for three main purposes. And ultimately, there are purposes that enable them to make better decisions. And we think of these digital twins as providing decision support. So there's been some mention of different levels of automation. We don't consider ourselves at doing the full automation, even where we do have an autonomous solution in the processing plant that I'll show you. It's still being verified and checked by a mining professional. And that seems to be the level of automation that people are prepared and wanting to use in the mining value chain at this point in time. But that doesn't mean in the future that won't evolve as the data or as our understanding of digital twin technology increases and people's acceptance of the technology increases. At this point in time, I can let you know that it is being used for prediction. So that means that digital twin models are enabling people to get a better feedback loop. That's that planning, and I'll show you some examples of that. Simulation, I guess this is what people think of when they think about digital twin, is that ability to ask questions of the model and see, if I do this, what will the effect be? I'll give you some examples of that as well. And finally, in the area of optimization, most optimization in mining is fairly, in the processing plant and even in drill and blast, is fairly static. It doesn't tend to respond to the variable inputs. And most optimization in mining is based upon the premise that if you can minimize the variability in the geology, then you will be able to get an improvement. So that's that smoothing out of variability, and then you run your set points, and if you can control your, if you can optimize and control the ore that's coming into the plant, then you'll get an uplift. And that is true, But what we're talking about with digital twin optimization is actually optimizing for variability. And there are some key points in the value chain where you can get a much bigger uplift if you optimize for that geological variability. And I'll give you examples of that in the case studies. So this presentation is structured around a series of case studies that will show you in practice how people are using digital twins in mine value chain optimization already. And that, when I say are using, I mean as users of the software, as opposed to as a consultant or as an advisor. These are tools that are software tools designed for people to use every day in their work. So one of the things that you might have noticed is the name of the company is Petra. Petra actually means rock. And the reason I named the company Petra is because I really believe that at the heart of optimization in mining is the ability to get the best results for the geology and the ore body that you have. And so whether you're talking about in the drill and blast area, or whether you're talking about crushing and how you blend the ore for different crushing operating plant strategies, whether you're talking about how you operate the mill, it all comes back to the ability to get the best result for that geology. And digital twinning as a technology is ideally suited for that, because you can learn through the machine learning how you achieved your best performance. And that's the principle behind this type of operational optimization and prediction and simulation. So we've got applications across the whole mine value chain. We're not showing it as a linear chain, which you'll often see people do in conferences. The reason we do it in this way is because we're showing that the geology is at the heart of, or the ore body is at the heart of the operation, and that if you're going to optimize, you need to be feeding back through the digital twin technology what you've learned in each of those processes and how you can get your best performance. So that's why it's drawn in that way, with the geology as the heart of it. And you can have all these processes around it and feedback using the data linkages to find out how you can get that best performance and how you can better control and predict what's going to happen next. So you may be wondering why this isn't currently being done, even in a manual process. So why don't people feed back their day-to-day performance and try and optimize day-to-day? There's some big challenges around integration of the mine value chain, which don't exist in other industries. So if you're speaking, there was a bit of a trend a few years ago where people were talking about we should be learning from the manufacturing sector because they use digital twin technologies, but it's quite a different process. So in a manufacturing process, you have known inputs to that process. And so what you're doing is optimizing by repeating and fine-tuning how you operate the plant, the control levers in that factory or that process. In mining, we don't have well-defined inputs for our processes. We have a very highly variable inputs. And so it's quite a different process. And so to apply digital twinning in a mining context, you need to be able to quantify the geology in some way mathematically in order to run an optimization, or categorize, maybe not quantitatively, but at least to classify or characterize the ore so that you can do that optimization. And to twin that and to make that useful in a operational context, that means being able to track the ore through that process, through the whole ore value chain, so you can see how the geology responds at each of those points in the value chain. And that is actually quite a difficult task. So a big part of digital twin modeling that in what we do is that tracking of the ore. And we put over the last 6 years, we've done a huge amount of research and development and now and refinement of that ore tracking technology. We don't need to use, it's all based on the data, and we don't need to use any devices to do that ore tracking. So it doesn't rely on trackers like physical tags or anything like that. It's once you've done that ore tracking exercise through stockpiles and using fleet management data, then you match that up to the downstream process, and that will give you over if you've tracked over a couple of years of data or more, sometimes up to 4 years data, you can build up a big data set. And that data set then enable that matching of each of the downstream processes, that provides the basis for building a machine learning model. So as part of my PhD, and probably a lot of mining professionals who've done research, we would normally be very limited in how much data we have to build an empirical model. You might be lucky if you had 100 data points to build a model, and you would normally use some sort of statistical method. Using this sort of ore tracking and merging of data using cloud technology, and when we do the ore tracking, we're running cloud applications that will run for days and using huge cloud resources in order to do that. That opens up a huge opportunity. So now when we go to build a model, instead of having 100 or 200 cases in your training data set that you'd use a statistical model, we've now got tens of thousands, even hundreds of thousands of training data points that you can use to build these models across the value chain. Another thing that's brought up in mining when we talk about advanced analytics, machine learning, and AI is there is a fair perception that there's a big problem with the data in mining. And that is true. There are certainly a lot of issues that need to be resolved in that data. But the point I would make around that is a lot of the mining software companies, including Petra, have had to, in order for the software to run, we have had to work out ways to manage the quality of the data. When we say manage the quality of the data, that means automatically. That means fixing the data in some ways. Might mean adjusting for sensor drift. It may mean doing calibrations regularly through the actuals, like the assay, for example, to online analyzers. And all this is being done in near real time, especially in the processing plant world, where you can get issues with sensors. The other thing that people who work with mining data a lot would tell you is that you can put in place multiple redundancies in your design so that you can have multiple models running, and then as the sensors drift or you get issues with a particular problem, the models will automatically detect an issue with some of the inputs to that model, and then they will be able to substitute and get different models. My colleague and technical director, Jelka, actually is going to be presenting on this very topic at the AusIMM's Future Mining Conference next week, if anyone would like to learn more about that aspect of digital twin technology. It's certainly a very important part of being successful in this area. So I promised I would go through some case studies now to show how it works and what the benefits are to people making decisions in operations. This case study goes back to 2018, and it's a mine in Laos, Banasai mine. It had a serious problem with recovery, and they would have incidents on not all the time, but a regular enough basis of their recovery. That's the amount of metal that they put into the plant compared to what they get out as product, dropping down to as low as 50%. And that was because they didn't know where in the ore that problematic ore was coming from. So it was being sent to the plant, and then they would have a low revenue from the plant for that period. So we were asked to help them to identify where that ore was coming from and locate it within the block model. So this is an example of a visualization showing the completion of the project where our machine learning models were able to predict this problem was coming from in the ore body. So we were not told anything about where these problem areas were. All we were given was the fleet management data, as well as the recovery or the tailings grade in this case. So we were actually predicting how much of the gold and silver was going to the tailings dam, and using that as in a relationship with that to the recovery. So within about 6 weeks, we had tracked all of the ore through to the plant, matched it up with the recovery data, built a machine learning model, and then that model is, as you can see there in the red and the pink, it's predicting every block, millions of blocks, and predicting for every block what its expected tailings grade will be. When what then that enabled the site to do was to change their life of mine planning to avoid mining and scheduling in those areas. And so they redid their life of mine to incorporate areas where that recovery meant that it was no longer considered, or it was considered waste at such a low recovery level. To improve the uptake of machine learning in mining, we have, and this is probably of interest to anyone applying digital twin technology, it's the more transparent that you can be in how you show and these technologies, the better uptake you'll get with this sort of technology. So being able to provide people with the variables. So what you can see on the left-hand side here are the variables that went into that model. And it also showing, I won't go into detail, but this is a SHAP plot for those who are familiar with machine learning interpretation skill, not skills, interpretive tools. But it gives you an idea of the complexity and the interactions that are going on between the variables. So a normal statistical model would can only model positive or negative correlations. It can't have sometimes positive, sometimes negative. And that's why machine learning models have been very good for this sort of digital twinning in mining. And we basically make sure that anyone using the software is able to find out all about the model variables and what the accuracy statistics are and what kind of model we're using as well. We used to not provide which machine learning models, but we now do provide that as part of the software reports and on the models. This second case study is very relevant to the theme of ESG and specific energy. So specific energy is the kilowatt hours per tonne that for comminution in that plant. So comminution is that process of grinding the ore or crushing the ore. And that specific energy is estimated using the pi data from the plant. So that's the kilowatt hours per tonne. Just notice the lights automatically went off then, they're back. So you get kilowatt hours per tonne, and we did a similar process where we matched it up to, and this abstract has been accepted now, and the paper has been accepted for the large open pit conference. That conference has been postponed, but we will be presenting in 2022 now. So that's what this one looks like. Similarly, track the ore to the plant. In this case, there were multiple mills, and then fed it back into the block model. They were then able to use that for the purpose of mine planning and know where and in this case, they were really wanting to use it for blending purposes rather than avoiding, like, they still wanted to mine it, but they didn't want to send all their really hard grinding material through the plant at the same time, because that was going to cause production problems. This is a case study in drill and blast digital twin simulations. So the previous case studies were max geomet. So that's where we're using the data to predict for planning purposes in the mine. This is a different application of digital twin technology. This is for simulation. And in this case, what we're enabling the engineer to do is, by matching up the geology to the drill and blast designs over a number of years, we're able to build a model of that. And then the digital twin model is designed, and I'll show you what the software looks like. The particular problem here was the minimizing the crusher downtime due to oversize. And so the drill and blast simulator is designed to show them how changing their drill and blast design will affect their downtime for each of the geological domains. So that's crusher downtime. This is what the application looks like. Each row is a different simulation result, and they have 2 crushers. The simulation shows them the fraction of blocks predicted to have downtime at the crusher for the different blast designs. And you can see here that the engineer has been trying different explosive densities and different, not different stemmings, just changing the explosive density actually. And then shows then what proportion of blocks sent to the crusher is expected to cause downtime. And so they can see here that there's two crushers actually, crusher 1 and crusher 2, and they're not behaving the same way. And this is what we mean by optimization. It's not just simulation, but you can also see the effect of your design on multiple downstream processes, and then optimize overall for each of those processes.
So, sorry, Penny, if
Yes.
we have a few more minutes, if we can.
Okay, yeah, I think I've only got 2 case studies left. Is it 20 minutes, the time, or 20?
It's 20 minutes, but yeah,
Okay.
past 20 minutes, yeah.
Okay, this is actually the last case study. So this is load and haul, similar process, match up the dig rate to the block model, and then you can then use it for predicting dig rate so that the the mining engineer can better, reduce the amount of over tracking and under tracking, because they've got a better estimate of how many trucks they actually need to maintain that dig rate. There's a processing plant case study too, but I realized I actually thought I had 25 minutes. Sorry about that. But we can, if people got questions about the processing one, perhaps they'll come back to me at another time. Thank you.
Thank you very much, Penny. Really appreciate it. I'm sorry that I had to.
No, my fault there.
The audience, I'm sure they would have questions, so let's leave that to at the end. So our next presentation, in fact, is a 3 flash presentation by my distinguished colleagues from University of Melbourne, Griffith University, and University South Australia. So our first presenter is my mentor and colleague, Professor Rajavi Fard, who is the Director of Center for Spatial Data Infrastructure Land Administration, also lead for the infrastructure platform at our faculty. So Abbas is going to talk about the state of art in digital twinning and a few case studies that we have done in the University of Melbourne. Abbas, over to you.
Thank you very much, Mohsen. Just let me share my screen. Just getting this. Just 1 second. Can you see the screen? So I don't know what is happening here.
It's not full screen. We can see the screen, but it's not the full screen.
Can you see my slide?
Yes. If you go to slideshow, I think it will show up.
What about now?
That's all good now.
All right. Thank you very much. It is absolutely a pleasure to meeting you all and have this opportunity to share with you some of our thoughts related to, the capabilities and also our thinking around this potential training hub. And in fact, I really enjoyed very much from the both colleagues that just presented, and from Russell and also from Penny, particularly from the different case studies, and which is actually making much more easier for us to share our thoughts around what we can do in the digital twin and location intelligence in particular, and taking that to supporting the digital economy. And it is also about how we can enable and in particular embedding sustainability into the mix and having resilience and a smart solution in that context. I think, again, going back to what we have heard from the first presentation, from some of the requirements or the changes in the market. And if you look at to the recent, the challenges and also the discussion worldwide around the climate change, and which is also bringing another layer of dimension that we need to really look at requirements and also how best we can put or design our digital twin, and in particular providing series of new strategic pathways to addressing mining requirements in particular. If you look at to the mapping mining to the Sustainable Development Goals, which is the recent report from the UN and the World Economic Forum, then we can actually see that the number of challenges that been addressed in this particular, and also how the whole world is traveling and is still very behind of the schedule on this. At the same time, there have been series of other strategic high level, again, the frameworks and also work that have been conducted by different communities. And again, going back to the IoT, for example, the role, as well as also AI and other areas that would actually, again, helping in that context, which we can better understand. When we look at to the interconnected future for mining in particular, and how we can look at to the smart mining by, again, getting this location intelligence more into this, by connecting series of elements, which would be from digital twin perspective for the physical assets, as well as also, again, the physical world into the digital world, but then providing a dynamic nature into that by having the sensor networks and having the direct data capturing and into the system, and mixing that one with series of automating the solutions that we can get. So therefore, we are talking about connected system, as well as also inclusive element that we can look at to the sustainability embedding into the design. And also at the same time, protecting approach and that resilience status of this. So therefore, that is really very crucial, that the way that we're going to work, and also providing this perhaps new trends into the industry and empowering the mining in particular. If you look at to some of the the challenges that we are facing from the different elements, major infrastructure, as well as also mining into this, then we can see that many of infrastructure that already been used and they're in the market from, and also resources. This is about, again, the series of the subsurface or above, the earth, also the resources that we have. We are seeing that according also to the recent, again, audit that have gone through, it's showcasing that the most infrastructure actually being used are also at the stage of repair. So therefore, we need to look at to the series of new elements that we can take care of this, and better perhaps addressing those kind of elements. But one of the core, the enabler into this space would be the way that the data have been captured or managed in that. And we can see in many of the elements that actually, when we look at today, also issues from the interdisciplinary challenge, which is around the resilience and sustainability into this, and also how we are leveraging off that type of technology, is the lack of an ecosystem, of open, harmonized, and interoperable information model and database across every aspects of that environment. And what we can see at on a screen, that now if you look at today how we are traveling and addressing that type of problem from the environment, or the way that we do the process, and applying that into digital twin, and also integrating solution in that, and having perhaps a standardized and also trusted type information. Therefore, with all the demands around the new infrastructure in all sectors, because of, again, the growing population, also economy, and also, again, the challenges we are facing with the climate change, and also aging infrastructure series of elements is coming through, and how we are going to addressing this sustainability in particular. So therefore, my message has been around this location intelligence and data that we're going to capture, we're going to analyze, and also visualizing through different techniques that we can go. So therefore, the journey that we have gone, and many, again, worked, and I'm very pleased again that Penny also have demonstrated a series of examples in that form, that how we go from this into the 3D, into the high definitions, and into the indoor and outdoor with all the assets. We see that then the digital twin, which would provide and facilitate as a technology, and that we can actually, again, look at to the system and also data ecosystem in that sense. Along the line of the spatial enabled digital twin would actually work, and the principles that Australia and New Zealand Land Information Council, which is the peak body for this, have actually demonstrated or developed, which we had also a pleasure to be part of the process of development of this, to understanding this, and also having digital representation of real world. But there is also the maturity matrix. There is a maturity level that actually would leading and helping us into that. From data perspective into the modeling, perspective, and then applying series of computation, modeling, forecasting, and simulating techniques in order to get those kind of capabilities mixing into these areas. Into that, then we actually look at to the securing the whole life of information as an asset via digital, again, information transformation here. And as you can see, there are 5, perhaps, sub-themes we are focusing on, from the capturing information, from, again, applying series of automation into that, as well as also adopting series of, again, capabilities like AI and machine learning and others into this. And then we have 2 enablers that actually we look at to the scalabilities and also the sensor network live data fit into this, and also having perhaps, there's a live the testbed environment that works, and then utilizing series of perhaps, decision supports, the capabilities in that space. And in particular, also applying top as a layer that sustainability, and also look at to the security in element. Just as an example, what we have done in our digital twin, which we had a pleasure working with Victorian government in that sense, and we developed series of elements and also capabilities into the mix that we have started developing capability, which we had actually opportunity to work with more than 20 departments, and we have captured over 1,200 data sets coming from different entities, integrating that into the fisherman's bend as an example, again, to providing series of capabilities. But at the same time, also we have captured and identified more than 130 use cases scenarios that actually that can or need to be developed, or there are a series of elements which currently we're trying to advancing some of the underground assets in that sense. So therefore, now we are able to look at to the, again, the integration of the assets and indoor and outdoor, as well as also series of, and if we apply these capabilities into the underground facilities and the mining and the size, and also when we look at the reservoir and every aspects of the work, then we can better, in fact, utilizing what we have already done, or there are elements that can be adopted. The last item that I would like to touch on is the major issues areas that for mining and also sustainabilities. In particular, there are 3 main core, or there's 3 goals that are directly affecting here, and also there are interrelationship between all the, the goals that we have and indicators into that, which when we look at to how our approach is going to be for adopting this, it would be, again, from the collecting the information to identifying the challenges, and then understanding the socioeconomy and also socio-environmental diversities into that, because the exercise is not purely a technical, it's a socio-technical, socio-economical exercise. Then we can visualize and then monitor the progress by series of analytics, and at the same time also developing actions for that and taking action into this and the plan. But interrelationship is very important. Many jurisdictions and also discipline, have started to applying their approach to addressing the sustainability, but they're taking very light view of this by direct relation, they only seeing that. However, there are indirect relation as well as also that interrelationship mapping that I mentioned is important depending to the requirements and priorities of the industry, and also for example, in this particular case, mining, we need to look at, for example, I'm just bringing this one from the work that we have done for the disaster management and resilience improvement, and series of priorities actually we put forward, and then we look at those to identify those kind of elements, because there are some what we call it from the trade-off that we have to understand. Some of them, they're going to have a positive impact, and some of them going to have a negative impact as a result of our action. So therefore, we believe that, again, the foundation that we are providing here and also direction would actually helping us to better addressing and also improving sustainability, at the same time improving efficiency and effectiveness of the whole processes. Thank you very much, Mohsen.
Thank you, Abbas. I really appreciate your quick presentation. Our next presentation is my colleague from Griffith University, Professor Rodney Seward. He is the Deputy Head for Research at School of Engineering and Built Environment. Rodney, over to you.
Thank you, Mason. Hopefully everyone can see that presentation now.
Yes.
So I'll be presenting mainly looking at sort of that socio-technical aspect that really Abbas sort of ended on, is the goals and objectives, and I guess the value proposition for moving towards digital is growing. And as far as my presentation, I really want to focus on these 4 particular areas, which is really around better integrated information management, understanding the business cases, readiness, maturity assessments, rethinking the business as usual of the organization before sort of going on that digital journey, and then thinking about what is the value that we get from those common data environments that we can create to eventually get to this common data environment enabled object-oriented decision support systems. So just sort of quickly moving into that, I guess from my perspective, we've been working a lot mainly with the utility sector, but also the infrastructure engineering sector, some mining clients, some government clients, and a lot of the time they're presented with solutions coming from proprietary companies who say we have the solution for you in the transition towards digital. And asking us about our advice as to whether those solutions are suitable for them. But when you scratch the surface and when it comes down to transitioning towards digital, a lot of the advice and a lot of our sort of thinking has sort of come around to digital twins is really the building blocks of that, is that better integrated information management, particularly with the information that you have available now in terms of existing enterprise management systems, asset management systems that you have that are quite disparate. They're removed from each other, but require an aspect of integration, talking to each other, and then some sprinkling of data science to get that value that you want to really see from some particular operational asset management decisions. So, you know, a big part of, I guess, the research and advisory that needs to happen around the technology is also understanding where different organizations are coming from. The mining industry has very small exploratory companies right through to the very sophisticated multinational mining companies. Each one of those companies is a different point in terms of their digital transformation, and they require an incremental step towards that better integrated information management, eventually working towards these sort of sentient digital twins of their assets that they have. And a big part of that, and that's where sort of the team that we've sort of assembled here for this digital engineering training center, is around understanding, where those organizations are in that journey, really getting to the bottom of what are the value propositions for them, understanding even from a social science point of view where their organization is at, where their people is at in terms of champions of digital change, people's training and support, and doing a very honest assessment of that, so that journey, those leaps that you make towards different levels of maturity are not too steep, and they're logical, and investments that are made add value, and they really link to the value proposition of that organization. And we've been working on that with a number of different, mainly water, electricity, utility companies, to understand where that value proposition is, and that point is where they need to undertake that change to get that value. And that requires a lot of sitting down with the entire life cycle of people involved in the management of the asset. So, we need to have the design, capital works teams, the build and operate teams really sitting together to understand where the data is coming from, the handover of that data, who's handing over that data, what is the quality of that data, ensuring that integrates well into the existing legacy systems, ensuring the legacy systems are lining up with the new systems that are in play, and understanding that value proposition, because we have a lot of objectives now, but when it comes down to it, a lot of the objectives of the organizations, whether particularly in the mining industry, a lot of it's obviously around process improvement, productivity improvement, in terms of the output of the mine, or the cost of obviously extracting the minerals. And the other side is around managing risk. So you really got to see, is it adding value from that point, or is it managing a risk? And risk could be anything from, safety, or it could be something around environment, moving towards sort of a carbon neutral site. All of these aspects are very much becoming part of the value proposition for digital. And if digital is done right, particularly around re-engineering that business as usual, so not just saying we do it this way now, and if we have these digital technologies, we have these sensors embedded on our trucks going around the mine site, we have this spatial data, or we have these digital twins, we can do this. But it's really about thinking about how the actual whole operational process will be managed with that digital technology, and then seeing where the benefits are and the value is for the organization. So, we're very much, as a group, we're very much across the digital spatial technologies, the data science, but we also have a very good people that are across that change management aspect, which is equally important to get a good outcome. Because if you can't get those, the people in your organization across the line upskilled and trained, then you won't achieve that value. So for us, and what we're really aiming to do in terms of digital transformation in the infrastructure, mining, utility sectors is really about creating those value adding, I call them common data environments. They may be 3-dimensional, 2-dimensional, it might be just integrating tabular data, but it's really about where is that value, and then moving, ultimately we can move towards those decision support systems at a object level, which is really about visualizing at objects, where they're 3-dimensional objects, being able to click on those objects and get all the data from them, all the predictive analytics from those objects, understand asset conditions, safety ratings, whatever it happens to be, and replicate what's happening in the physical asset with the digital asset. We as a group are really working already with a number of industry partners across different sectors, but aiming to work more, obviously, with the mining and energy sectors around getting those really intelligent CDE-enabled object-oriented decision support systems going. So that's really my presentation there. It's just really a nice wrap up to say that we're really across the technologies, but also very mindful of the where the different mining companies are at in their digital journey, and we have the skills to help them transition along that journey.
Thank you, Rodney. Our next presentation is by Professor Marcus Stumpler from University of South Australia. Marcus leads the UniSA's Artificial Intelligence Lab and Interoperability Lab. So Marcus, over to you. And we have 5 minutes, 6 minutes, Marcus, if you can, please.
Can you see my screen?
Yes, we can. Yes.
Very good. So yes, to continue the journey of the digital twin and the pieces that go into that very complex puzzle, the area that we are looking at is the actual management of asset data and the curation of those data over the lifetime of the asset. I represent the Industrial AI Research Center from UniSA, so we work in intelligent decision support in a variety of areas. Basically, what we do is we develop particular technological approaches that can then be generalized to solutions for particular industry sectors, Industry 4.0 infrastructure, transport, utilities, energy. We also work in defense and healthcare. The key aspect of our work that is relevant to the training center here is the work on the management and the curation of asset data. So we have, just giving you a selection of the projects that we have worked in, dealt with projects on the risk management of assets in power and energy industries. This led to questions of interoperability. How do you bring data together from different source systems, first legacy systems, then other systems that are built to put together the different data that are required to build a accurate digital twin from in a particular ecosystem, extracting maintenance data from things like, for example, maintenance records or repair records, the management of digital assets, the designs of plant equipment or vehicles, for example. And current projects involve things such as the asset tracking and analytics computation for shipyards, and the digital technologies and interoperability program at the Future Energy Exports COC that looks at interoperability in the energy sector, in particular LNG and hydrogen, and where we are working on the methods for developing interoperable ecosystems for analytics platforms, so that owner operators can put together complex analytic solutions from offerings by different solution providers. Behind these different projects is a set of common methodologies and technologies where I'm not going to go into detail. Some of these have been mentioned already in the presentations before. So in particular, we deal from the question of the collection, aggregation, and compression of asset data, the issue of interoperability, bringing together data from different sources, systems by different vendors, to allow the construction of the complete information picture about a digital twin, the proper methods and models for the description and annotation of these data, the cleansing, removal of noise or incorrect data, the linking of data from different sources, and the long-term archiving. And we do this also in the context of international standardization. So what we're seeing here is a image out of an ongoing standardization process through ISO Technical Committee 184, which we have achieved by support for different growth centers to provide with an Australian mirror committee, so that Australian companies can contribute to the international standards process and have their say in how the technologies that are standardized contribute to their particular business models. And what this diagram shows, this is out of ISO TS 18101, a current ongoing standardization process, the life cycle of an asset and the way in which the data flows over the different life cycle stages are used to produce a digital twin and compute feedback loops that allow the optimization of the use of that twin. I'm not going to go through this slide in detail. That shows the interoperability picture from the perspective of some of the industry partners we are working with. So these are international standards that have to do with asset management and asset data analytics. And we are working on projects for the integration and interoperation between these standards and the demonstration of the outcomes on what is known as the industrial interoperability pilot series that feed into this ISO standardization process. And to finish, I'll just point out briefly the scope of the analytics that can be executed on those asset data. This is out of a single project that we're doing. It's not mining, it's a shipyard analytics, but it deals with the assets involved in the construction of a ship that make up the shipyard and then partly move into the ship over the lifetime of that product. And this has to do both with the situational awareness of warehouse operations, fusion of data from different sources, the tracking of assets, prediction of their behavior, of their utilization to enable better planning, looking back into the past, providing traceability and certification to enable identification of problem issues and tracing back concerns to the root cause of, for example, non-conformant situations, classic optimization of the operations based on the collected and curated data, and finally the visualization and the overview of the build progress and the depiction of the analytics outcomes for particular entities in the overall process. That's it. Thank you.
Thank you so much, Marcus, for finishing your presentation on time. So we have still 10 minutes or so. So I would like to invite the panel members to turn on your cameras, please. So then the audience will see you. And the audience, please, if you have any questions, you can type in the Q&A box there. We have one question already there. So the question is about how about using healthy mining for everyday zero carbon and combining mining with substitution for future example, all substitution energy, solar, zero waste technology production, and sort of basically greener energy. I guess, Russell, you had a reference to that in your presentation. Maybe if you can start answering that question.
Yeah, certainly. You know, there's a lot of transformation going on, as I mentioned. There's certainly a lot of research and development in that space. I know yesterday I was meeting with the heavy industries CRC HILT, which is a consortia group of collaborators that recently received CRC funding, developing certainly a lot of channels around not only circular economy, but utilizing waste streams from wastewater treatment plants or from mining or from other industries or from food and agriculture, using all of those as substitutes and energy sources. So trying to map all of that is really a key initiative that there's a lot of R&D going on at the moment, certainly.
Thank you, Russell. Penny, did you have anything to add in your case studies? Was there anything related to green energies and better substitution?
Yeah, I mentioned the one about the specific energy, which is the kilowatt hours per ton. In mining comminution, which is the process of grinding the rock up really small, it consumes, I think it's something like 2% of the world's electricity. And so being able to choose using existing optimization techniques, blocks which have a lower energy intensity will reduce the amount of energy used by the mining sector. It's probably in the incremental. It's not like a transformative technology, but it's certainly something that can be done now. And that gives it benefit in given the current, what would you call it, time frames that we've got to work with around reducing our carbon footprint. So there are things that we can do incrementally, and I think that what we're doing there with the specific energy and reducing that, improving the efficiency of the mine value chain is a contributing factor, but it's not going to be the transformation that the industry is looking for.
Okay, thank you. While we wait for other question, I have one question, and perhaps Russell and Petra is more directed to you. And in the context of what you mentioned, Russell, about the commercialization challenges, how critical you see having a highly trained workforce like doctoral, postdoctoral workforce is important for transforming the mining companies, a mining company, or in general the mining sector in Australia?
I'll go first. I think it's really critical where we're going. I think, as we move into a data economy, there's certainly going to be different skills. I guess I would envision as at a regional mine site that there would still be quite a range of skills, but a key component of digital transformation will certainly be around training. There's no question about that. I can't comment on how many PhDs would be required, but it's certainly around a different type of working that would then lend itself to the amount of data analytics, interpretation, and then implementation. And I think, as others have spoken about, the quality of data and quantity of data is really a critical component, and that some of that comes from sensors. There's certainly then the analytics, and then decision making, and then implementation. And each one of those four legs to the chair, I guess, each one of those is really critical, and each one requires, in many cases, different skill sets, while also having an understanding of the others. Okay,
thank you. And perhaps, Benny, your company is obviously led by a highly skilled workforce. Do you working with many companies, in mining companies, do you see the need for further training in digital engineering in the mining sector in general?
Yeah, I think one of the advantages of postgraduate education training is that it usually involves a lot of transdisciplinary learning. So even back when I did my PhD, which is a long time ago now, probably 15 years or so, I learned about minerals processing. I had to do statistics training. And I think it's that transdisciplinary learning you get from a postgraduate qualification that you don't get usually through undergraduate training, which tends to be focused on specific skills to do a specific job that exists now. But the difference with a postgraduate degree is it's really training you to create new technologies that don't exist. And the reason why that training tends to result in that outcome for those people, including me, is that you can make connections in your understanding that you wouldn't normally get exposed to through that process. Because a PhD really is about creating new knowledge, and to create new knowledge, you need to make new connections. And those connections come often through learning about areas that you didn't know about in the past. It's way outside of your domain. So I do believe it's got a separate role in our country's, in Australia's preparedness for digital, economies and digital economy growth. Yeah, that would be my experience.
Excellent, thank you. I think question by Ajibadi that has been answered. There is one question. I think this should be for Penny again. It says, you talked how machine learning optimizes mining operations. Data is the key to machine learning. How do you assess Australian mining sector capability in collecting, recording, and using mining critical data? Is the sector ready to take full advantage of the growing ML technology, machine learning technology?
Yeah, look, I can see both arguments. There's two arguments often in this space of data quality. One of the arguments goes, we need to produce a really good data infrastructure and that common data environment. And I agree that creating a common data environment would be brilliant, especially if it's interoperable and will enable a huge amount of technology. The situation though, out in the field is that it costs a lot of money to do those things. And in order for mining companies to invest in that type of common data environment, they need to show value and they need to do it incrementally. So it's not that common for a company. Some will do it, will go invest millions in a data kind of environment or data platform, but many are looking to find the low-hanging fruit. And where can we find value with what we've already got? And so that's where solutions like what we have and others, there's others out there too, put a lot of effort into, we call it data fusion, but I guess it's a common data environment for a particular application. So we're not building the ultimate platform for data, environment, but we will build a version of that data that is required to achieve a certain value creation for that mining operation. So I would love it if companies had really, fabulous data platforms that were fully interoperable, and but the costs can be quite prohibitive. And some of the investments that have been made, unfortunately, have not been getting the, they're not getting the returns on those investments for various technical reasons about how those environments have been built.
Yep. Thank you. There is another question for you, Penny, and that is about the energy reduction. An example of the impact on energy reduction. Can you share an example? And is this something that can be put in place in short term for real gains? So I think you mentioned something before, but if there's
I think that's a bit like the one I spoke about.
Yeah.
So maybe the question came in.
Yeah.
Might have come in, but yes, it is a thing that can be done now. It is an incremental improvement, and it doesn't really fit in the transformation that the industry really needs, but it certainly would result, because comminution is such a huge energy impact on the value chain, it certainly can make a significant decrease in emissions, but it's not going to reduce them to like net zero by 2050 using that type of thing.
Yeah, thank you, Penny. We're coming to the end, but I have one question related to what Penny said, that it's the cost of data collection can be huge cost to put together a data information center. Perhaps a question about, I don't know if you mind to talk about the cost of the digital twin for Fisherman's Bend and how that helped the government, the state government, to further secure some substantial budget from the government to do a digital twin for Victoria.
Yeah, thank you very much, Mohsen. Yes, the proof of concept that we work with Victorian government to demonstrating some of the earlier capabilities that can be adopted into the, different operation of the state. That actually also helped the case that the Victorian government, through the Land Victoria, they have put forward, and they have received just a few months back, received $42 million actually from commitment from the government to scaling up that work for the entire Victoria. So that is the digital twin Victoria. Now that there is a heavy again program led by Delft and Land Use Victoria to running this. And I think if we look at to the cost, because we also applied series of new innovation into the land modernization and land administration modernization, and through a study that we have done under the project with World Bank, we also came out with a figure that would be any dollar investment securing, and that actually would return $3 into the new capabilities, and also reduction of series of duplications. And this is just for those jurisdictions that they have already have a good level of maturity. So therefore, if we are applying this into the domain that they are in the very, for example, earlier stage of the work, I think they would actually get much more from the ratio. And also, it is not just about the cost benefit, because it's already evident that actually it's going to be covered and returned, but it's actually really the fact that how we can afford to not have this. While now we have a new potential in front of ourselves, we can change the way that we operate. I think that's what we look at, to the new level of capability that we can provide into the, all the practitioners in that sense. I'll stop here.
Thank you, Abbas. And Marcus, did you want to add anything?
Yeah, I would just have one comment on the question of the cost of building interoperable systems. I think the key aspect is that if done right, if you use an ecosystem-oriented approach, you can build these interoperable systems without significant overhead, right? And the key part is that ultimately, this is something that reduces cost as you make data available and you help improve the quality of your operations significantly. That I think is the key part, right? Break down the silos, provide bridges between the silos. You do not have to rebuild your whole landscape. You just have to provide the pathways to make what is already available effectively usable. That is the key point.
Excellent. Thank you, Marcus. And perhaps to wrap up, Rodney, do you have any comments to add here?
It's just a repeat of what Marcus said. The bridges between the existing, disparate enterprise, management data management systems. That's what I see time and time again, is just really some IT investment to connect them in a logical way and a sensible way, and then work out ways to add value with that data, better decisions, and then you target the low-hanging fruit first in terms of the value proposition, and then you incrementally get more complex in terms of adding, IoT sensors and things like that. So it is an incremental journey. It's not you have to, start again with your existing data sets. It just never works. Well, not never, but it's very hard to take 100 years of legacy asset data and all of a sudden just start again, and that's what I see with different organizations. Start incrementally.
Excellent. Thank you very much, Rodney, and I also thank again our presenters, Russell, Penny, Abbas, Rodney, and Marcus, and also thank you the audience for sticking around. We went 5 minutes or 6 minutes over time. My apologies, I'm not good in chairing the sessions, but yeah, thank you again. And if you have any questions about our training center, the digital training center, you can contact me, and happy to answer any question. If you are interested to join the training center, more than happy to have a discussion. Thank you.
Thank you very much.
Thank you.
Thank you.
Thank you. Bye.